In this video, we look at the derivative of e to the x, and as there are no rules at this point to discover that, we're going to go back to the definition of the derivative. So we're going to use the f prime of x definition, so that's the limit as h goes to 0 of f of x plus h minus f of x divided by h. And our f of x plus h would be e to the x plus h, and our f of x is e to the x. And it doesn't seem like there's much to do here. Again, we can't plug zero in for h. You can use a property of exponents to change e to the x plus h into a product. And so that becomes e to the x times e to the h minus e to the x divided by h. And now we can see that we can probably factor out an e to the x. So that's, and actually we can factor it out and move it outside the limit because it doesn't have any h's in it. So if you do that, you're left with e to the h minus a 1 divided by h. And so now this whole process boils down to, do we know this limit? And again, there's not much to do here. So we would have to appeal to either a graph, or there might be some other clever way to do this problem. But I want to appeal to a graph and note that this ends up equaling 1. And so the derivative of e to the x equals e to the x, which is pretty amazing when you think about it. It's its own derivative. That means that if you look at the graph of e to the x and go to any point on that graph, the y value of that point is also the same as the slope of the tangent line at that moment, which is pretty amazing. So, just a quick chain rule problem involving e to the x. If you had to find the derivative of y equals e to the sine x, well then you would just use the chain rule. So the derivative of e to the sine of x, well, the derivative of e to the anything is just itself, so it's going to be e to the sine x. But then we need to times by the derivative of sine of x. In other words, the quote inside function. So the derivative of sine of x is cosine of x. So there's the derivative of e to the x, and a little example using the chain rule. Now that we know the derivative of e to the x, we can get the derivative of other exponential functions where the base is not e. So if we have f of x equaling a to the x, with our a being a positive number that's not equal to 1, we can use our knowledge of the derivative of e to actually find its derivative. And the trick is to use what we know. We know the derivative of e to the x, and a to the x can be written as e to a power. It can be written as e to the ln of a to the x, because e and ln are inverses of each other. And what I'm going to do here too is I'm going to use a property of logs, which is going to allow me to move this x down here in front of the ln, so it becomes e to the x ln e to the x times ln of a, which maybe you might want to view as e to the ln of a x. So if f of x equals a to the x, which is the same as e to the ln of a times x, well then its derivative is just going to be the derivative of e to the ln of a times x. But the derivative of e to the anything is itself. And then we're going to have to times by ln of a, because that's the derivative of the inside part. Now we're almost done. If you think about it, I mean, it would be e to the ln of a times x is a little awkward way of representing our answer, but e to the ln of a times x is just another name. If you look above to the right, it's another name for a to the x. So it's just a to the x times ln of a. And that's the derivative. That's the derivative of a to the x. And so notice that this kind of encapsulates the derivative of e to the x too, because if our a is e, if a equals e, then f prime of x would be e to the x times ln of e, but ln of e is just equal to 1. But in general, the derivative of any exponential is going to be that itself times the natural log of the base. So here's a chain rule problem for us. The derivative of 4 to the 3x, well, it's just going to be itself 4 to the 3x times ln of the base, ln of 4. So that's just the derivative of the exponential part. But then we've got it times by the derivative of 3x using the chain rule. And that derivative is 3. So our final answer would be 4 to the 3x times ln of 4 times 3.